Thank you kindly to the organizers for having invited me to cover the last section of this very interesting event. So many interesting topics already emerged in the last 3 days, and I think that we are going to conclude very well. Really very interesting lectures. And it's a real pleasure for me to introduce the first two speakers, Lia Morra and Antonio Santangelo. Lia Morra is assistant professor at the Polytechnic di Torino, where she originally obtained a PhD degree in computer engineering. In 2006, she joined IM3D to develop computer-aided diagnosis solutions for early cancer detection and screening. From 2014 to 2017, she served as IM3D Chief Scientific Officer. She's currently a member of Interdepartmental Center Smart Data, as well as a member of GRAINS, Graphics and Intelligent Systems Group. Her research interests are mainly computer vision, pattern recognition, and medical image interpretation. She has authored numerous papers in the engineering, computer science, and radiology domains. She's author of L'origine dei linguaggi for ICOS in 1992, and co-author with Silvia Del Santo and Loredana Correale of Artificial Intelligence in Medical Imaging from Theory to Clinical Practice for Taylor and Francis Group in 2021. And Antonio Santangelo is Semiotics Senior Researcher specialized in audiovisual studies and the Executive Director at Nexa Center for Internet and Society. He teaches semiotics at the eCampus University and the University of Turin. His main interest is the development of a mature vision of semiotics as a social science that can be used at the same time as an analytical and as a creative tool to understand and also to predict the meaning people may give to their experience of communication products and to their mutual interactions around them. In the last few years, he has been working on artificial intelligence and on the way it can affect the public sphere, in particular the construction of public opinion. Because of this expertise, he has contributed to draw up the Italian white paper on artificial intelligence and public administration, together with the Agency for Digital Italy. His publications include, among others, Sociosemiotica dell'audiovisivo for Arachne in 2013, Le radici della televisione intermediale for Arachne in 2012, and Narrazione e realtà with Guido Ferraro in 2017. Thank you, Lia and Antonio, please.
Okay, so today my duty is just to introduce you to the Fresco project, which is the technological branch of the Facets project, and to leave the floor to Lia Morra, who developed Fresco. Fresco is meant to analyze images through artificial intelligence, roughly to understand their meaning, even if as semioticians we know that understanding the meaning is a wide and complex concept. Anyway, today we will show you how it works relying on some images of my Facebook profile, because Fresco analyzes images of Facebook and Instagram profiles of people. We started by telling Lia and the engineers who developed Fresco that we didn't want just to recognize the contents of images, not to tell their meaning, because we strongly believe that images have mainly connotative meanings. So we wanted our tools to give us the chance of telling the connotative meaning of images, and I hope you can guess that the images I chose here have a connotative meaning too. And so we asked Lia to develop tools that can make us aware that images have some pertinent traits inside of them that can lead us to make connotative interpretations of them. and Lia later will tell you what she did. Because we work on Facebook and Instagram profiles, we believe that we work even on the identity of people, no? Because people communicate their identities through their Facebook and Instagram profiles. And of course, because we are inside of a European project on faces, we believe that the face has a very important role in communicating identity. But we also thought since the beginning that face is not the only content, no, that people put into their Facebook and Instagram profiles to tell their identity, no, because many times they believe that being in a place, no, is important to tell their identity. Being together with people is important, and Massimo is recognizing an old photo of us when we were younger, or doing politics, and there is also Christian Bacco. And doing politics is also important sometimes, no, for people, etc., etc. There are many things that you can find in an image, no, that are important to tell the identity of people. So we told Lia and the engineers that helped us that we wanted to work on faces, but only on facets of our identities, no? It's something more nuanced. And to guide their work, we made a starting meeting, in which we told her which were our research questions, no, that had to be developed. And here you find some of them, no, because we are many. There are many researchers, no, inside of Facets, and every one of us has research questions. So here you can see, when self-representing themselves, do people want to show themselves happy, or do they prefer to show other moods? Is their face the focus of their profile? How many do not put their face at the center of their profile? Is there anyone who does not show their face in their profile? If so, what does it show? Do people usually show themselves alone or in company? In general, do they prefer to show themselves in the center of the picture, or do they put something else in the center of the picture? Is the context in which they show themselves important? Where do they prefer to show themselves? Which objects do they prefer to show next to or on themselves? Do they use filters? What kind of colors do they prefer to use, etc., etc.? You see that these are plastic and figurative questions, and so Lia had to develop tools to find out inside the images, no, plastic and figurative pertinent traits, no, and of course, as it is always done in these cases, we imagine to cross such data with the data that we took by surveys, no, because the people who gave us their images had to fill a survey, and so with social, demographic, and cultural data. Crossing such data, we hope to find some connotative interpretations of the images, meaning that we hope to categorize, no, people, and finding out whether they are adventurous people or travelers, or people who believe that their social status is very important, etc., etc. And later we will show you an application on the images of my personal Facebook profile of the tools that Lia developed. But now it's time to leave the floor to Lia.
Thank you, Antonio, for this very nice introduction to the project. Thank you all for having me here. This has been a very informative and inspiring couple of days. Today, I would like to present you what we're doing. It is very much a work in progress. So we have already some results, some implementations, but we still have a long way to go to fully develop the concept, in my opinion. Fresco, which stands for face representation in e-society through computational observation, was developed with the goal of enabling what we would call big data analytics, which is essentially a quantitative tool on large-scale visual collections. And visual data is, in our language, an unstructured data. So in order to use analytics, we need to reduce the image to a set of numbers and symbols that we can use in computational models. We wanted to do this, but we also wanted to build a tool which was useful for semiotics, and therefore the quantitative indexes that we extract must be somehow aligned with semiotic principles. This means that we need to decompose image in a set of fundamental characteristics or traits, but we also need to account for the different elements that compose a picture, which is not only a face, but it is usually an individual in context. For example, this is my Instagram picture, and I realized that on Instagram I never publish photos of my face. So this is the closest that you can see my actual figure on Instagram. And there are a number of elements. You can see Turin in the background, you can see the River Po, and of course also there is the element of what you cannot see, because I'm trying to obviously disguise myself. This was not done intentionally. In retrospect, I realized in retrospect by going back to my own pictures. This concept is not absolutely new. This is I would say now a foundation of our society. This is an image taken from an article which appeared in 2019 when an outage on Facebook, a bug in the interface, did not stop showing pictures. And instead of pictures, they showed the tags that were automatically extracted by Facebook. This is done not only for surveillance purposes, it is also an accessibility principle to help visually impaired make sense and interpret the social media content, which is visual. But it exposed a fundamental truth of which most users were absolutely not aware at the time, that their images were not only pictures, they were data. And this is similar to what we actually would like to do, but under different design principles, I believe. The underlying design principles of Fresco are both scientific and technical. From the scientific perspective, we want to extend beyond typical plastic characteristics, such as, for example, the histogram of the image and all the indexes that can be derived from the histogram, which do not really tell us much about the semantics of the semantic content of the image, and really also extend to the communicative practices that people put in place, where they decide what to publish and what not to publish. We also wanted to design something that could support both confirmatory and exploratory analysis, because we realized that in some cases some researchers had very strong hypotheses of what was happening. On the other hand, we tend to be guided by our immediate circle and what we observe in our immediate social circle. But if we look beyond the our social circle, we might uncover practices that we didn't even know existed. So we also need exploratory tools that can let hypotheses, interpretation hypotheses emerge from the data itself. From the technical point of view, we try to follow an open and reproducible approach, which meant exploiting as much as possible open source or publicly available components. And also you need some data management principles in order to be able to trace back all the indexes to the actual version of the algorithms that extracted it, especially since the technology evolves so rapidly. We wanted the platform to be easy, expansible. We also have a huge problem with compliance with the GDPR regulations, which meant for not only to they needed to have consent from the users, which I will talk about, but also they need to avoid third-party services, avoid, for example, Google Analytics or other third-party services, cloud platforms, and also crowdsourcing type platforms such as Amazon Mechanical Turk, because the face is a potential biometric information, and since these images come from the internet, there is also potential for re-identification. If people if Tiger try to search for your image on the internet, that they might be able to get back to your identity, even if the image are anonymized. Starting from these principles, we designed the first part of Fresco. We designed and implemented the first part of Fresco, which decomposes the image, which first collects the images and then decomposes them into quantitative traits that were extracted using what we would call AI tool. I prefer to call them machine vision tools. This is standard discriminative AI, so we're not talking about generative AI, but rather systems that try to measure or classify images. And from the point of view of data collection, we had to develop a rather complex infrastructure. By the way, if you want to donate your images, you can use the QR and we will point to our infrastructure. There is a web interface where users, a multi-language web interface where users can donate their images, compile, fill in this smart disease survey, but also, for example, we asked them to anonymize images of other people that did not consent to donate the pictures. And then there is, of course, a number of technical issues that I won't go into the detail, but for example, that are important if you want to do this kind of research. For example, you need to completely separate the physical storage of personal information and images. All of these has a deeply profound impact on the amount of type of images that you can collect. So there is a fundamental trade-off between the representativity of your corpus and the compliance with the GDPR rules, because avoiding bypassing the need for consent requires a really strong motivations that your research is so important that you can bypass, has so large societal implications that you can actually bypass the need for consent. In order to try and make the data collection process more appealing, we also try to insert some gamification elements for the images that are donated are processed through a sort of deep dream restitution that generates a new version of the image that was also meant to make people reflect about, you know, how AI is used to sort of spy or interpret our images, but also we need to understand and interpret AI. So it was meant to be this kind of reflection on the duality of this relationship. But moving on to the actual pertinent traits, we decided to try and focus on all the elements. So certainly we have to start from the face, but we often also have the body, the context, so the places, the objects, the interactions between people and such objects, The more traditional plastic features, such as the color palette, whether you're using a grayscale, whether you're using strong saturated images or not, all these global characteristics that somehow affect our perception and our categorization of a certain image. There could be also text, which you extract, and so forth. To give you some examples, for example, to analyze the image, we use a collection of tools, including MediaPipe, which is a tool by Google that can extract the face mesh, so all the a set of key points that decompose, that are used to not only interpret and classify faces, but also to pose them, to understand their pose with respect to a frame of reference. The head pose, which is not really, the tool is called deep gaze, but the gaze is not, direction is not necessarily the head pose. So we have to make a distinction, which is basically the angle of the head with respect to the camera. And all face expression, we call emotion recognition. I prefer to use the term expression, because this is not, we don't really know if the emotion is there. We just know what the signs of the emotions are. And this is actually the output of the algorithm, is actually this set of numbers that will give you an emotion, but also a score, which tells you how much the algorithm is confident, and will give you a more nuanced, can allow you to make a more nuanced interpretation, not just in binary terms, but also in terms of degrees of happiness or degrees of disgust or whatever. I will talk a little bit later about the scene, because the scene recognition is troublesome to use, but this is also something that we can obtain, so we can recognize whether the scene is indoor or outdoor, and to a certain extent also where the person is. And upcoming, we don't have it yet, but we are also looking into generating captions automatically. Now we have these multimodal systems, like Aldo was saying, that can actually put together and mix text and image, which has the advantage that we have many more tools for text analytics. But of course, there is a problem of how the caption is actually descriptive or imaginative, because some of the captions may be satirical or comical, because they are trained on human-generated captions. So the idea is that we go from this depiction actually to this. Of course, we don't really store the data in Excel. This is we extract in an Excel format for analysis. But here you can see that all of these indexes can be put together with the social demographic characteristics, such as the gender, education, relationship, whether the religion, whether the person has children or not. And we will try to put these together to understand what is the relationship. Of course, most of the analytics tools are based on the concept of correlation, which does not imply causality. So we need an external model of the world in order to actually perceive, to distinguish between the two. And this is where human interpretation comes in, because these models do not have yet a separate model of the world of these underlying principles, and therefore and cultural principles, and therefore we need to separate correlation from causality, and this cannot be done without a human interpretation. It is crude. I understand that it is crude, but to a certain extent, but this is the only way that I know of to do actual quantitative analysis and to put together a large corpus, because we cannot see more than a handful of images at the time. We don't have that capacity. There are, of course, a number of challenges in applying machine vision, and I think it is very important that we are straightforward about the challenges and what these tools can and cannot do. One of the challenges is corpus representativity, which is not necessarily an issue with the computational backbone, but it is due to the need for consent, which introduces a self-selection bias. We also have a problem of how to aggregate some of these indicators. For example, the polls. In the opening remarks, Maria Giulia made a lot of very interesting comments about how we can interpret the polls in a deeper sense, but also how can we aggregate poses from different images to understand them better, because the pose the pose is not necessarily by itself a set of numbers that we can intuitively interpret. So we need also to assign meaning back to the numerical indicators. There is also an issue that algorithms are not 100% accurate, which in my opinion might not necessarily be a problem if the noise is random, because by the law of large numbers, the errors will average out if the number of images is sufficiently large. But there could be systematic errors, such as those related to the problem of open world recognition. So if there are systematic errors, they will not average out, even if we increase the number of images. So we need to be aware of those potential systematic errors. One of the problems, and this is especially a problem with classification tools, such as scene classification, is that they are trained under the closed word assumption. In machine learning, in logic and machine learning, the term is used with different, slightly different meaning. For machine classification, it means that the network is not aware that other classes exist. So if the network was trained to recognize only, in this case, 365 classes, it will try to put everything in one of those classes, even when it is not possible. So it will work very well when the scene is within the training distribution, but it may give you completely unjustified result when the sample is a so-called out of distribution. So it was not seen during training, or it's not seen altogether. So for example, in this case, the network probably recognized some of the background as a potential shower, and therefore will give you this label, even though from a human perspective, this is not justified. So we need a way, as a countermeasure, we need a set of heuristics or rule to understand if the particular image is within the training distribution of that classifier, because otherwise we cannot trust the results. And this must be understood.
Okay, now an application of what Lia told you. If you see a selection of the images of my Facebook profile, you may notice that I don't often use images such as this one, so close-ups of my face to show how beautiful I am, something like this, maybe because I don't think to be so beautiful, I don't know. But anyway, I prefer to show pictures in which I am happy and happily integrated in a context, which most of the times is nature. It can be the mountains or the seaside, etc. But many other times are my friends. You know, I like to show myself happy in that context. So I believe that the meaning of my Facebook profile images is what you have just heard. And I used Fresco to see whether it is able to give me some hints through the database that it constructs, analyzing my images, that this must be the interpretation of my images. And in my opinion, it succeeded because, for example, I ask you to notice the blurry voice, no, blurry false, means that behind me, the context is always visible, no? It is always visible. You can see that I am happy. It recognizes that I am happy. I am happy to hear. It also recognizes very well, in this case, the context. It says that I am happy in a ski slope. I am happy in front of a crevasse.
Which is very Antonio.
Yeah. It also recognizes the colors. No, the colors are very important, no, because it recognizes that I am happy when I face cold colors, no, because for me I'm much more happy. I don't know why in these situations. And it also notices, if you see the depth estimation, that the context is very wide, no, in the image. It is very important. With Lia, we discussed, because, for example, here, this image mixes two things that are important to me: friendship and the nature. And so friendship is the biggest part, no, of this photograph, because we are together with my best friend who risks his life going to the mountains with me. But the context is also very important, because we calculated it is 25%, no, more or less, of the image. So, of course, I can tell you, well, these are pertinent traits of the image that are recognized by Fresco. They finish inside of the database of Fresco. If I know what they may mean, I can make connotative interpretations of the images. If I also go and see how many people have blurry false, and how many people have a similar, no, palette of colors, how many people have a similar scene category recognition, etc., I can also understand which category of people I belong to, because as a semiotician, I don't believe to be unique. I believe to be interpretable by being classified in some classes that make sense, no? Because science are classes and narratives are classes, etc., etc. And so I can understand whether I am the only one to believe that publishing images of me inside a very important context like nature or friendship. Yes, if I am the only one, or if there are many people doing that inside the number of people that donated their images to Fresco. And now I leave the floor to Lia again.
Okay. Sorry.
Yes.
Yes, I know that if I can take just 2 minutes to show what is next, what would be our next steps. Like I said before, I wanted this platform also to allow researchers to explore the collection and to build a specific classification system based on the collection. And we know that deep neural networks are very good at learning representations. This stems from the so-called latent manifold hypothesis. And we also know, and this is fairly recent, that obtaining a good representation does not necessarily require labels. We now have self-supervised and unsupervised systems that can build these sort of spaces, latent spaces that we can explore. And maybe labels. So we don't need labels to build a good representations, but we can assign labels if we have a good representation. So the other line of Fresco is exploits this sort of self-supervised clustering interactive exploration to try and make sense of a collection. We don't have a collection yet to analyze. So we built a synthetic collection based on public datasets, including portraits, selfies, indoor and outdoor scenes, animals, especially pets, art, cartoons, everything that could be potentially used as a symbolic or real face in a Facebook profile. And we have explored different ways of building these latent space. Of course, the real latent space is low dimensional by deep learning standard, but very high dimensional by human standard. So we have to project it to 2 dimension in order to be able to navigate. And we can use these representations to actually browse the collection and interpret. I will jump forward in the video. We can see that, for example, that if we select nearby points in this data structure, we can probably see some patterns emerge in the way that people are representing themselves. And therefore, what we would like to understand in the future, right now we're going from image to traits through AI, and then we interpret those traits. But our next step probably would be to use AI to reach directly to the interpretation. For example, we were discussing about using the flux model to actually build a sort of semiotic AI. But then once we have the interpretation by the AI, we need to go back to the traits. Otherwise, we don't know why we have this particular classification, and therefore we have to reverse the problem. And this will be our next step.